Sixth grade, welcome to the second half of lesson 1 for science class. Yesterday we got started, we were talking about matter and what matter is, and we learned some of the characteristics of matter. Mass, the amount of substance, the amount of matter in that space, volume, the amount of space it takes up, and then we ended yesterday talking about the difference between weight and mass. Remember, weight can change because weight's measuring gravity's force, mass doesn't change. So if I'm an astronaut, I have the same amount of matter inside me, whether I'm standing here or I'm on the moon. But my weight's going to change because the moon doesn't have nearly the gravity that Earth does, so it's not pulling me as hard. So my weight would be 1/6 on the moon, but the amount of me, the mass, doesn't change. All right, we're going to talk about the next step then. It says, did anyone ever ask you the riddle, which weighs more, a pound of feathers or a pound of lead? Do you know the answer? Most of us probably said a pound of lead, but because we don't read very carefully. The answer is both. They weigh the same. It's a pound. It's a pound of feathers. It's a pound of lead. But 1 pound of feathers would be a lot larger than 1 pound of lead. In other words, I need a huge monster box to have a pound of feathers. I need a very small little piece of lead, size-wise, to actually weigh a pound. How can that be? The reason is that the matter that makes up lead is more tightly packed than the matter that makes up feathers. The lead has a greater density. What is density? Density is a measure of the amount of matter in a given space. Another way to say this is density is mass per unit of volume. So guys, density, the measure of the amount of matter in a given space. If I remember mass up here, mass was just the amount of matter that makes up the object. So density is how tightly is it packed in there. Mass just what's the total amount. Okay? Think of density this way. Suppose you have a cube of lead that measures 1 centimeter on each side. Its volume would be 1 cubic centimeter. Its mass would be 11.5 grams. The same size cube of cork would have the same volume, 1 cubic centimeter, but its mass is only 0.24 grams. The particles that make up matter are more tightly packed in lead than they are in cork. The lead cube would be heavier. Okay? Finding density of a substance is easy if you know the mass and the volume. You use the formula. Density equals mass divided by volume. So you got number 2 in your notes. To find it, mass, and you need to have mass and volume, and to do that you take mass and you divide it by the volume. For example, suppose you have an object that has a mass of 30 and has a volume of 15. What is the density? You take 30, you divide it by 15, you get an answer of 2. 1 cubic centimeter of this substance has a mass of 2 grams. Okay, why do we care about density? What does that mean for us? Well, it means this stuff. By now you might be wondering how knowing the density of a substance is useful. You can use density to identify an unknown substance. Number 3. Every substance has a particular density. For example, if a small cube of lead or a large lead pipe, the density of the lead is the same. It's 11.35 grams per cubic centimeter. Also, the density of a particular substance usually differs from that of the other one. So if I did the math, guys, and I got 11.35, it's lead. And what they're saying is most substances all have their own unique densities so that I can use it to be able to figure things out. Suppose you have an unknown piece of metal and you want to find out what it is. First, measure its mass and its volume. Then, use the mass and volume to calculate the density. Once you know the density, you can use the table, like the one on this page, to identify the metal. If you find that the density of the unknown metal is 10.5 grams per cubic centimeter, what do you have? So I go here, I find 10.50, and I know that I have silver. Okay, so I can use it to find an unknown substance. Up here, guys, you have a disaster happening. We got an oil spill. Oil is less dense than water. Number 4 in your notes here. That's why oil that is spilled in an accident is likely to wash up on the beach, because it sits on top of it and the waves move it in. So we say, guys, water and oil don't mix. And so because of that, one way we can clean up oil spills, guys, is we literally bring in, they're called a skimmer. And we just go right across this and we scoop up this oil because it doesn't sink to the bottom. Okay? So then you have another picture of densities. You got different liquids that they dye different colors, and different substances are floating on the different liquids to be able to do those things. So that's how we're using density. Density is a physical property. Density is just one of the properties that can be used to describe matter. You learned that the density of copper is 8.96 grams per cubic centimeter. Look at the copper in the picture below. What other properties do you know? So you got this copper going on here. Copper, copper, copper. Did you describe copper as shiny and solid? Those are some of copper's physical properties. Physical properties of matter are those that can be seen or measured without changing the substance into something else. The piece of copper in the picture shows two other physical properties. The copper is malleable. So guys, you're over here, this is physical properties. It can be seen or measured, and it doesn't. So without changing the substance. Moving on. We're talking copper being malleable. It means that it can be spread or shaped by being pounded with a hammer or by being forced through rollers. Okay, so malleable, guys, pounded with a hammer. Number 6, I can form it into sheets. So I can have flat coppers. And I'm going to punch a little circle out of this, call it a penny. Okay? Copper can also be made into wire. That's the term called ductile. So I don't know how familiar you are with malleable and ductile, but we got to learn those. We'll talk about them in this chapter, and then later on in other chapters it's going to come up as well. Physical properties. You might recognize copper as material that makes up electrical wires. That's due to another physical property, its ability to conduct heat and electricity. Number 8 in your notes. Wood does not have or conduct heat or electricity well, which is why cooking spoons are often made of wood. So we have those wooden spoons that we cook with. Why? Because if I set that on my pan, it's not going to all of a sudden get hot. If I set a metal spoon on our hand, and some of us cook with metal spoons, guys, and if you set it and rested it on the hot kettle, it would transfer and the spoon would become hot. Okay? Other physical properties of matter include whether a substance can be dissolved in a different one, whether it's magnetic, and the temperature at which the substance freezes and boils. So those was number 9 in your notes. A substance's physical properties are the same no matter how much of it there is. So I have a little piece of copper. A little piece of copper has all those properties. Sorry about that. It doesn't matter what's going on with it. It is all those things. Okay, so they gave you a little things here, guys. The temperature at which liquids boils, physical. The temperature at which it freezes is a physical one. Pure water is this one. And guys, water's not pure really, so it has different temperatures, slight different temperatures. The opposite of physical properties is chemical properties. Another way to describe matter is to describe its chemical properties. A substance's chemical properties tell how the substance forms new substances when it reacts with something. So we're going to get a new substance. So for example, wood in the fireplace is burning. As the wood burns, it changes into new substances. It changes into it changes into gases, it gives off light, gives off heat. There's major changes, guys. That's a chemical property. The substance's ability to burn is called its flammability. Wood is flammable, iron is not. So chemical properties give you something new. Flammability is your ability to burn. That's a chemical property, being flammable. Here's another really good one. Iron, when it messes with oxygen, rusts. That changes the materials that make up iron. It's not strong anymore. It falls apart, okay? Water doesn't burn. That's flammability. That's a chemical property. Copper combines with oxygen to form a mineral, cuprite. That's different minerals that'll turn those things green, like the Statue of Liberty. Top of your page, guys, is another chemical property here. It says many substances are changed when they get mixed with acids. Acids will change those things to different substances. You can see this one bubbling and giving it off. So that's a chemical property. You can tell that the zinc nail is changing into another substance in the acid because of the bubbles it releases. Gold, it's just sitting in there. So there's different chemical reactions. We'll talk about the next one, guys, when we talk about chemical changes and physical changes, to talk about the difference of those two. All right, we finished up lesson 1, guys. That means you have a worksheet that goes along with it, with the matching sections with a lot of these vocabulary words to be able to do. Best of luck with it. Have a great weekend. Oh, wait a minute, don't have a great weekend yet. We should add some extra credit into this. Extra credit is, I've heard this. If you put a zinc nail in your stomach, it'll digest itself in less than 3 days. Don't try that, please. I've also heard if you put the right kind of nail in Coke soda, it'll digest itself. I shouldn't use the word digest. It'll dissolve to nothing because Coke has some acid in it. Maybe you want to try that. Find a zinc nail and put it in Coke to see if it works. Okay, what we want to put on for extra credit? Nails dissolve in acid. But it depends on the nail. Have a good one.